Hi everyone and welcome back to Dev Portal. In today's video, we are going to explore one of the most important data structure in Java collection framework, the set. We will dive into what a set is, the key features and the difference between HashSet, LinkedHashSet and TreeSet. We will also explain the practical code example, common use cases and the methods these classes provide to efficiently manage data. Let's get started. A set in Java is an unordered collection that does not allow duplicate elements. Sets are useful in scenario where we want to ensure uniqueness, such as maintaining the unique IDs or removing duplicates from the collection. If we talk about the key characteristics of sets, then only unique elements are stored. If we try to add the same element multiple times, it will be ignored. And sets generally does not preserve the insertion order, though there are exceptions. And it is efficient in providing fast lookups for checking the presence of an element. Now if we talk about the common use cases, then it maintains the unique items, like we can store the unique user IDs. In that place we can use the set. Then removing the duplicates, we can use the set. Suppose you want to remove the entities from the collection, and set perform mathematical operations such as unique, intersection and differences as well. Java provides three main implementations of set interface. One is the HashSet, then LinkedHashSet and TreeSet. Each implements has a unique feature suited for the different use cases. If we talk about HashSet, then it does not maintain the order and it is quite fast in performance. HashSet provides constant time complexity of O of big O of 1 for insertion, deletion and lookups. And the best use case is that when we only care about the uniqueness, not the order in which elements are inserted. Now let's look at a small example to understand in a better way. So let me create HashSet first. So HashSet, and I will only allow integers, and name will be the set equal to new HashSet. Let me import, and now what I will do, first let me add few elements in this set. So set.add, to add the element we need to use the add method, and I will add 10, then set.add 20, and what I will do, I will try to add 10 again and we will see what output it will print. So as we know, set does not allow duplicates, so it will ignore the line number 9 operation. So if I try to print this set, let me save the code and run it for you. You can see that it is printing 10 only once, not twice. It means it has ignored the next operation of insertion of the 10, and we can also see that the order of insertion is not maintained in the HashSet. Now let's talk about LinkedHashSet. It maintains the insertion order as well. That is the one point, that unlike HashSet, LinkedHashSet maintains the order in which elements are added. If we talk about performance, it is slightly slower compared to HashSet due to order overhead, but it is still provide big O of 1 annotation performance on basic operations. The best use case is that when we need to preserve insertion order along with the uniqueness. Now let's look at how we can work with the LinkedHashSet. So let me remove this code and I will type LinkedHashSet, and again I will allow only integer new LinkedHashSet. Let me remove the unnecessary import. Now again what I will do, I will add few elements. Set.add, first let me add 10, then let me add 20, and now I will add 30, and we will see the order of and we will see in which order it is printing the elements. So let me save the code and run, and you can see it is printing the elements in the order we have inserted. Now if I try to add 10 again, set.add, it will ignore that operation. Sysout set. Let me run the code. So you can see it has ignored the operation at line number 10 where we are asking to insert 10 again. So duplicates are not allowed and order of insertion is maintained when we talk about the LinkedHashSet. Now let's discuss about the TreeSet. A TreeSet stores the elements in the ascending order by default, that is the one point, and it is slightly slower compared to the HashSet and LinkedHashSet. The time complexity is big of log n because it uses the balanced binary search tree for the storage. When we talk about the use case, then use TreeSet when we need elements to be sorted automatically. Now let's look at example to understand that. So let me remove this code again, and I will create TreeSet now. TreeSet, and again I will only allow integer. Integer set is equal to new TreeSet. Let me import. Now let me add few elements here. Set.add. Suppose I am adding 20. Then set.add 10 and set.add 30. Now if I try to print the set here, so as we told, TreeSet store the elements in ascending order by default. Let me show you few more methods. So sys out set.first, and one more is set.last. So what it will do, first will print the first element and last will print the last value of the set. So you can see in the console as well. So earlier we talked about that set also allows some mathematical operations like union, intersection and differences. Now it's time to look those examples as well. So again let me remove the code, and what I will do, first let me create HashSet, and I will allow only integer, and it will be the set1 equal to new HashSet, and I will add few elements here. Set1.add 1, set1.add 2, and set1.add 3. In the same way, what I will do, I will create one more set. It will be the set2, and let me change the values here first, not values, the name of the variable, and here I will add 2, 3 and 4. So first let me show you the union operation. So for that I need to create one more set, HashSet, and it will store integer, and variable name will be the union equal to new HashSet, and what I will do, I will pass set1 here. So by default it will store the set1 values. Let me show you that as well. Union, if I try to print, let me save and run. So you can see it is printing 1, 2, 3. Now what we will do, we will ask him to add the set2 as well. So union dot add all, we will want to add all the elements of set2. Now if let me save and run the code, and you can see it is printing 1, 2, 3, 4. So this is about union. Now let's see the example of intersection. So for that again I need to create HashSet of integer, and what intersection do, it will print the common values. So for that let me create the object first. It will be the new HashSet, and I will provide set1 again. So by default set1 values got copied into the intersection object. Now I will ask to retain. Retain is one method that is present, and we will use this, and we will ask you need to retain the common elements which are present in set1 and set2. Not in set1 means in intersection object and set2. So if I add sysout statement, let me print the values. Now you can see it is printing 2, 3. In set1 1, 2, 3 is present, and in set2 2, 3, 4 is present. So the common elements are 2 and 3. It is printing. This is about intersection. Now look at example of difference. So for that again I need to create the one more object of HashSet integer. It will store, this is difference equal to new HashSet, and again I will provide set1. Now what I will do, I need to ask object to remove the common elements which is present in difference and in set2. So for that, diff dot remove, one method is there, remove all, and I need to provide this set. So set2 I will provide, and I will add sysout statement, and I will print the diff object. So you can see in the console it is only printing 1, because in set1 1, 2, 3 is present, and in set2 2, 3, 4 is present. So it has removed the common elements which is 2 and 3, and only left a value is 1, that is printing in the console. Let me explain you again. Union combines element from both the sets without duplicates. If we talk about intersection, it finds the common elements between both the sets, and difference finds elements that are in first set but not in the second one. To wrap up, sets are essential when we need unique elements in our collection depending on our requirement. We can use HashSet when order does not matters, LinkedHashSet when we need to maintain the insertion order, and TreeSet when we need elements to be sorted automatically. Each implementation has its unique strength, so choose the one that fits to your requirement best. In the next video, we will move on the maps in Java, which store the data in key value pair. So don't forget to like, subscribe and hit the bell icon to stay updated with our latest tutorial. See you in the next video.